So how do you approach almost any word problem? What's the first thing you're looking for? Players. And what are the players in this problem? Dimes and nickels. So number of. Ooh, sweet. Yeah, these I can't get high off. At least you can see what I'm writing. Dimes and nickels. They're the players. So I try to get you to realize these steps so that if you see a word problem, you're freaking out because it's got stuff in it, you don't just start attacking it with the steps. What are the parts of this problem? What are doing something together? That's where you start. Which one is going to be just a Which one's going to be just a single variable?
Nickels.
Why?
Because it just said
seven more dimes than nickels. So I gotta know nickels first. So if I knew nickels was what?
N.
That's crazy. Then how do I write how many dimes she has? N plus 7. Let me stop right there. It's okay if that step doesn't make sense, but you have to ask. If you don't ask and you come up later with it, that's not as good. Does everybody see that? I mean, that is almost the standard first step, first few steps. Whether the players write them in English, then you start worrying about the math. Who's the thing that everybody else depends on? And here's only two things. So who does the other guy depend on? Nickels. Dimes depends on nickels. And now that I know there's n nickels, I know there's how many dimes? N plus 7.
This is kind of an English class now for grammar.
A little bit, yeah, of course. Yeah. Because math doesn't exist entirely on its own. We still have to use some words to talk about it. Okay, so now what do I do with those players now? The equation comes from how these guys interact. What do they do in this problem? Somehow they make $2.05. So does anybody remember what we did? You don't have to do what we did, but it makes it a little bit easier.
You said something about cents, and so nickels would be 5 N.
Yeah, but so instead of using $2.05, what's a little bit better to use to make things
Cents.
cents? So how many cents is $2.05? 205 cents. I like it. You just come into the post office with pockets full of change. I don't want to buy a book of some stamps. Holy shit.
Pay for your car.
I like it. Pay for your car with cents on it.
That's a lot.
Does anybody see this? Because I got the lights turned off. That's very cool.
Yes. It's better.
Wait till you get older, kids. All right. So how many cents do I get from each nickel?
5.
5. So how much total cents do I have?
5 N.
And then from each dime, for each one of these dimes, yeah, I get 10 cents. You guys, this idea shows up so many times. Yes?
How come we're not putting a D next to the 10?
I like it. Nowhere do I have the variable D. But why didn't I need to use a completely separate variable for dimes? Are nickels and dimes completely separate? Are they not related at all in this problem?
Oh, no.
There's a relationship, right? If I knew that I had 2 nickels, how many dimes do I have? If I knew that I had 2 nickels,
One.
dime.
what is happening? Help me. No. All right.
Just
guys.
finish what you were saying.
No, I understand. I understand what just happened. Not how many dimes would you give me if I gave you 2. In this problem, if she had 2 dimes, with the relationship they give me, how many nickels would she have?
4.
What's happening?
2 dimes?
7 more dimes than nickels. If I had 2
So
nickels.
you would have to add the 7, or no, you would have to add
Yes.
to the nickels.
Okay, so stop. What's funny to me is you guys all got the n plus 7, which is the algebra, which is supposed to be the harder thing. If I give you a number, and it says she has 7 more dimes than nickels, so she had 2 nickels, she must have had how many dimes? 9. Because what's it say? 7 more. This is the hard step, which is, I love it actually. It's sort of neat if you guys, this is easier, because I'm like, dude, algebra is your first language. It kicks ass. But I don't believe that. What you're not used to is what I just said. I gave you an actual value for the thing we don't know, and I did that yesterday. If I knew that I had 2 nickels, I'd have 9 dimes. You'd add 7 to it. So that's why whatever the nickels is, dimes isn't something completely separate. It can't be whatever it wants to be. It has to be 7 more than what this guy is. But that's a really good question, because later this semester we're going to look at when we need more than one variable. But here, these are connected directly. So he can't be whatever the shit he wants to be. He must be 7 more than what this guy is. So I don't need to give him his own variable. Does that make sense? If nickels changes, dimes changes with it. So we only need one variable because that controls everything. Okay, maybe. One variable to control them all. And then, so if I got 5 cents for every nickel, 10 cents for every dime, that makes a total of 205 in this problem. And then you can solve that bad boy, right? Go ahead and do that. Yes. Sure. Exactly. Because if you multiply each of these by 100, make them into cents, you don't have to. So again, just like we did last time, if you wanted to, you could say $0.05 per nickel, $0.10 per dime. Get out of there. Gives you $2.05, right? $2.05. If you multiply each one of these by 100, you get to where we got. How did we get to where we got now? We just started by changing things to cents. So math doesn't care when you make an adjustment like that. It's just going to come out to the same place eventually. All right, you guys doing all right? Maybe this. You all right? All right, let's see. Let me catch up to you guys. So I get 5n plus 10n plus 70, right? Right? Distribute, bam, bam. So you get 15n, I can subtract 70, equals 135.
Okay, that's right.
And thankfully 15 goes into that. Yeah, there. And x, and x, and x. And is? 9. Boom. So what's that mean? 9 nickels. And so that means how many dimes? 16 dimes. You guys all right? I mean, the minute we get the question answered, I've already got set up how to answer the question. Because I know n is this answer, and n plus 7, bam, is the other answer.
Yeah.
Now, if you don't put some kind of units, I'm going to be a jackass and put here bananas, light years. So,
Bitcoins.
don't make me be more of a jackass than I am, but I will come in with my jackassedness and put something silly there if you don't put units. And plus take points off. Oh, shit. That's the important thing, yes?
For word problems, do we have to answer in full sentences?
No. I like it. So I'm not going to completely convert this to an English class. You must use an Oxford comma. You must use correct. No. Sorry. Go.
Where is the 15n? Because, never mind.
5 in it,
less
yeah.
than,
Yeah.
right.
So I'm hoping at this point, getting to here should be the hard step. After this point should be the easy step. If you are still having trouble solving equations, you desperately need to focus on that, because that's going to be like your last part of a problem. It's going to be solving equations. You want that to be relatively easy. I like it. Okay. Let's see if we can find a different type. These are all the same type. Ooh, I like this one. Let's try this one. Danny. Danny boy. That's the pipes. The pipes are called. So Danny has $2.14. So he's got more money than she did. Worth of pennies and nickels in his piggy bank. Number of nickels is 2 more than 10 times the number of pennies. So go ahead and try to do that. Try to set that problem up. What about? I'm sorry? I don't want to do it right now. I'm going to do this one. Yeah. Sorry. Now look, real quick, guys. The more you start to look at it this way, that problem is the same problem we just did. The more what I just said makes sense, the more you get algebra. That's the exact same ideas. Is it the same amount of money? No. Is it the same coins? No. Is it the exact same ideas? Yes. So in a way, it's the same problem. I know you're looking at me like, whatever you say, man. Yes.
I'm just gonna guess that I don't know.
What's up?
Would it
Sorry?
be?
All right. What's the first step? What are the players?
Nickels and pennies.
So write that down. You
Yeah,
got
yeah,
it?
dude.
Okay.
Pennies.
And who's going to have to be a letter?
Pennies.
Pennies. Everybody with that? Because the number of nickels is blah, 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 pennies. So I got to know what the pennies is first. So you can call pennies P if you want to, sure.
Nickels would be like, so it'd be like P.
2 more than 10 times the number of pennies.
So it'd be P, it would be 2P.
2 more than 10 times. What's 10 times pennies? 10p. And 2 more than that? Yeah, 10p plus 2.
Ow.
I like it. What's up? 2 plus 10p is beautiful. Because the addition doesn't matter which order.
So the
I like it.
times part attaches itself to the.
Definitely, because it's 10 times pennies.
Okay.
So it must be 10 times p, because you called pennies p.
No.
Kick ass. Of course, $2.14 is 214 cents. You don't have to do that if you don't want to. It's fine. You can keep all the decimals in there. All right. But some of you guys are going to do this. So how many cents for every penny? All right, so I got 1p. Plus, for each one of these, 5. Now watch, I'll have somebody do this.
No.
Why is that wrong? Because you got cents plus cents equals dollars. That equation doesn't make sense. Excuse me for that. Doesn't, screw it, doesn't make sense. I want to get the source. Cents. Yeah. So that's a really fundamental thing. An equation actually has to make physical sense. If I'm adding cents to cents, I better end up with cents on the other side, or else it's bullshit to begin with. You like it? Maybe. And now it's the same thing, really. Right? So P plus 50P plus 10. Yeah, 51P. And that goes in nice.
Oh, 2. Wait, no.
5 goes into 20 4 times. 50 times 4 is 200, and 4 times 1 is 4. Yeah, so P was 4. 4 what? 4 pennies. And then how many nickels then? Yeah, 10 times 4 plus 2, I got 42 nickels. Circle. No matter how much I say how important this step is, several of you are not going to do this step. And that'll drive me a little insane. Because then you won't set up the equation correctly. You'll get an answer, you'll circle it, and then you'll go on when there's actually 2 answers to this, right? So if you do this, it makes it easier to set the equation. It makes it easier to make sure you answer all the questions. But still, if you don't want to do this, all right. Go ahead. Make mistakes.
So, how did you get like the 42
Say again, sir?
The 42 nickels.
Yeah, because we know P is 4, right?
Yeah.
And then nickels is 10 times P plus 2. So 10 times 4, because P is 4, yeah. So that's what I mean. I almost think of this as dominoes. Once I get this figured out, it falls back and figures out the other dude. Wherever I see P, I know it's 4. And what's really cool then is since everything is dependent on that one variable, once I know it, I know everything. I just have to go back and actually write the shit down so that you get credit for it. Yeah, exactly. Okay, maybe. You guys doing all right?
Maybe.
All right, let's try a different type. Here we go. I love it. Perfect. Here we go. At a school concert, the total value of tickets sold was $1,506. Student tickets sold for 6, and adult tickets sold for 9. The number of adult tickets sold was 5. Let's show the number of. When you look through this, I know now we're talking about tickets, right? We're talking about tickets. We're talking about money that they made at this freaking concert. Can anybody see how that really is the same exact problem as what we just did? I mean, you don't have to shake your head if you're not really able to see that, but situations change, but the idea is the same. I got 2 players. One of them is going to be a variable. The other one can build off of that. I can make an equation. So go ahead and try to set that up.
Trying to figure out how many student tickets were sold.
Yeah, we're trying to figure out how many total tickets, how many student and adult tickets were sold. Exactly. So at least try to get the players down and try to translate them into math, and then I'll catch up to you.
Did you mean 50 on that?
No,
Oh,
because what's
51?
P plus 50P? How many P's? 51P.
Oh, because
I got
of the
1P plus
right,
50
right.
gives me
Okay.
51.
I thought it was just 5 that, or
Oh.
slash.
Yeah, but
That's
then of
why
course
I was
we
saying, where did you get it?
distribute. Yeah,
Okay.
that's
Yeah,
where
yeah.
the 50 came. Yeah. Okay. All right, let me catch up to you guys. Oh, yes. Oh. Okay. Well, yeah, it looks like you got the right idea. Yeah. Yeah. I like it. All right. So what's the number of student tickets and adult tickets, right? As if adults can't be students, but oh. I love how students get a discount, but I don't get it. I should get like 30 times that discount for a minute. I'll get it. Huh? Which one is going to be just a single letter? Bless you.
Student tickets.
Let's see what. So it says the number of adult tickets was 5 less than 3 times the number of student tickets. So it looks like adult tickets depends on student tickets. So I got to know what student tickets were first. I'm not going to call it S because my 5s look like S's. So I can call it X. Why not? Let's go be old school. Yeah, let's be basic. I call them basic. So how many adult tickets were sold then? 5 less than 3 times. What's 3 times the number of student tickets?
3x.
3x. And I want to make that 5 less, so what do I do to 3x? Subtract 5 from it. Don't write this backwards, or else you're saying that you sold negative adult tickets. What would that mean?
Did we give them one?
Gave them
Or-
away.
No, the adults came and gave you tickets. Here's a ticket for you. Thanks. Does everybody see that? Less than, again, is the most evil phrase in English because math says, oh, that's English doing some weird shit. 5 less than is that thing minus 5. Does everybody see that? That's the only one that makes you have to go out of order. All right, and so now, so what does this represent again exactly? This right here, what's it represent?
Student tickets sold.
Number of student tickets sold. And I want my equation to have what as a result? It's blah blah equals what? What's going to be on the equal side? $1,506, right?
Yep.
So I can't just say this plus this equals 1506. That makes no sense because I got number of tickets plus number of tickets equals money. Well, how much money did I make for each student? $6 for each student, right?
Right.
Right? They don't make any money, so we charge them $3 less. I guess that's going to save their life. So 6 times for each student plus how much for each adult?
$9.
9 for each of these. So 6 for each of these plus 9 for each of these gives me, now I got money plus money equals
money.
even more money.
That's
More money, more problems. That's all right. I can try out. See what it feels like to make more problems so I can make some more money. Yes?
In the test, we do everything, but we didn't get the answer at the end.
So thankfully you have a teacher that doesn't grade you as if you're a Scantron, right? So I will give you partial credit. So if you make one mistake somewhere, especially sucks if you make a mistake at the very beginning of a problem. I'll take points off for that one thing, and then if you do everything else correctly off of that, I won't take any more points. I, of course, had a bunch of teachers that once you made one mistake, if the answer is wrong, the whole damn thing is wrong. I'm like, and that's not what math is supposed to be. Is everybody cool with that? Do you guys see how that's exactly the same thing as the pennies and nickels? Because we did 5 times number of nickels and 10 times number of dimes, for example, right? This is so much money times how many plus so much money times how many. Thankfully, there's no cents involved, so I didn't have to do any weird decimal shit, right? So 6x plus 27x minus 45.
33x.
33x. Let's add 45. Nice palindrome. You guys know what palindrome is, right? Like race car. What's race car backwards?
Isn't it
Race
this
car.
week? This
Huh?
week? This palindrome week, isn't it?
It is palindrome week. Thank you. I knew that's why it was in my brain. This whole week, the dates are palindromes. So, like, what's today? Got it. 91019. 91019. It works backwards and forwards, yeah. So it's like it's almost it's like a tier down from Pi Day. You guys know what Pi Day is? You know what pi is roughly? 3 point. So March 14th, 3.14. March 14th, all the math geeks of the world go, it's Pi Day, let's eat some pie, and wear shirts with pie. I'm gonna do the same thing. All right.
Hey, I was all about like point, like,
I'm with you. I didn't slam, did I? What's this wrong with you? No. So then how do I, and of course I just, how do I know this is divisible by 3?
3 times 5 is 15. 5.
Yeah, 1 and 5 and 5 and 1 is 12 is a multiple of 3. So at least I know 3 goes in, but 33 does go in, right? Because 11 has palindromic
Oh boy.
results when you do like 11 times 11 and so forth. Anyway, so what do you get when you do that? Anybody do that?
47.
What is it?
47.
47? Okay. 47 what? Students. Tickets. Student tickets. And so how many tickets? Student tickets. And then how many adult tickets?
3.
Yeah, 3 times 47 minus 5 is 141. Is that right? Minus 5, 136?
Yeah, 136.
Oh, come on, it's my one skill with the ship. Gotta show off every now and then. Woohoo!
Oh,
Hey, look, the math teacher, how could you know?
you just take 3 from where you got it from the beginning, times 47.
Yeah, because I know the expression for adult tickets. The only reason I don't know what it is as a number is I didn't know what X is, but now I do. So now I know what the shit that is. Can't like it. Maybe. Okay. Sure. Oh, good. All right. It's always nice to know that. Let's see. Blah blah blah. All right. Well, all right. I want to do some different kind of problems. Ooh. All right. one. Whoa. This one's kind of neat. A whale watching ship had 40 paying passengers on board. The total collected from the tickets was $11.96. Full fare passengers paid $32 each, and reduced fare passengers paid $26 each. This is even a different type. So can you guys get a feel, even if you're not sure why, can you, it's not just because we're talking about whale watching instead of a concert or whatever, it's different type. They don't tell me the number of full fare was 7 less than twice. Do you see that? There's nothing like that in there. But they do give me one more piece of information than what we had before. They tell me the total number of passengers. They didn't tell me the total number of tickets here. Because instead they told me this relationship. You got to give me something. So, here's just kind of cool. Let's see if you guys get this. If there were 11, it doesn't matter. 11 full fare, how many reduced fare would there be? So let me ask you this question. How many total passengers were there? 40. So if 11 of them paid full fare, how many paid reduced fare? 29. Right? What about if 30 paid full fare? 10 paid reduced fare. Is that cool? And some of you guys are like, hopefully are like, yeah, it's 40 freaking passengers. So what they gave me, stay with me now, they gave me a total number. So here's what's really cool. What do you keep doing? Why did you get 29 the first time when I said 11 full fare? Because of course what did you do? 40 minus 11 to see what was left, right? Do you have a clue how much of either type? No. In fact, that's the first step, right? How many full fare? That's the 2 players. So let's attack this like anything. I wanted to first point out how this is a little different, but you don't even have to know that going in. What's your first step? What are the players? Full fare, reduced fare, I like it. Palindrome, I like it. All right. It's weird that the word palindrome is not a palindrome. I didn't see that. So I got number of full fare, reduced fare. We still don't have to give these each their own variable because they are still related directly. Do I know either one of these? Is there anything that tells me which one to know first? No. Because I know what they total to me. So if this was 11, this would have been 40 minus 11. If this was 30, this is 40 minus 30. So this is x, because I don't have a freaking clue, then this one has to be 40 minus x. They don't give me a relationship like they did before, 3 more than twice this one is the other one. They don't say any of that up here, do they? They don't have to because they do give me another piece of information. There's a total of 40. This happens every time there's a total. One of them is going to be x because you don't know either one of them, but then the other one has to be total minus x.
So does it matter if it's full fare or reduced?
It doesn't matter.
Okay.
I got it curious. I don't know why I'm so excited. No, it doesn't matter. Right? I really want you to understand. If somebody else were to do this problem and were to call this one x and this one 40 minus x,
It would be different.
the answers would come out to be the same. In fact, let's see if you guys can bear with me. Maybe I will do it both ways. What the shit. But you guys see, so if I would have said there were a total of 200 people at the concert, some of them were adults, some of them were kids. So I can call one of those two things, adults and kids. One would be x, the other one would have been 200 minus x to be the rest. And you guys know this is true. You immediately did it when I said, what if there were 11 of this type? Well, then of course there's 29 of the other type. Because I do 40 minus 11 to see what the other type is. Well, I don't know how much this one is. Well, then it's 40 minus that shit to be the other one. And what is x plus 40 minus x? 40. Don't the x's cancel? So they add up to be frickin' 40, don't they? Okay, maybe. Some of you guys look pained. I'm sorry. I'm also used to that, so I'm sorry. I'm a math teacher after all. Okay. So then what can I bring in? What's the main idea, really? This is just the number of. What's the idea behind the equation? Money seems to be the idea behind everything so far. Full fare paid $32 each. Good, 32 times X. How much money am I making off of these guys? 32 times each one of them. Is everybody cool with that by itself? We've done that several times today, but just to make sure, if there were 3 full fare, how much money would I make off of them? 32 times 3. Well, I do know how many there were. There were X of them. So how much money did I make from them? 32 times X, 32 per each one. Plus, how much did I make for each of these guys? What was it, sorry? 26? So 32 for each of these, plus 26 for each of these, would give me 1196. So you can't fall into the trap of every problem will be the same. You can recognize when a problem will be like another problem, though. This one definitely wasn't like the other one because they didn't give me that 7 less than twice the other one. They didn't give that to me. They gave me something else. And now you solve this the same way. Right? We've been doing, let's see. Oh, what is 26 times 40? 1,040? Yeah, sounds right. Yeah. Minus 20, you should have said, you're the math boy. Now this is kind of nice. 32 minus 26. Subtract. Now I'm thinking about taxes, freaking 1040. Equals 156. Thankfully 6 goes into that. 26. That's neat. So what's that mean?
26 is paid full fare.
Good, 26 full fare.
40 minus 26? 14.
14 paid reduced.
Oh, there.
Is that all right? And again, I understand as a student that you see a problem like this and you're like, who the shit doesn't know in charge of the ship how many paid what? I mean, that's insane. But the skills we're learning about algebra by itself is useful in situations that apply to the real world, but those equations would obviously be a little more difficult than the one we get from this situation, right? So the simpler you want the situation to be, the less immediate sense it makes. Like the guy who put money in the bank and forgot how much money he put. I'm like, well,